Okay, this time we'll be adding three formulas to the formulas we have discussed so far. This time we'll be adding integrals giving inverse trigonometric functions. So we have these three formulas. Again, these are all derived from the derivative of inverse trigonometric functions. Or we just took the antiderivative to get these formulas. Okay, so example, if we recall, the derivative of arc sine u, that gives us du over the square root of 1 minus u squared. So this is in this form, but dito ang a natin is equal to 1. But how about if this is any other number, or this is any number other than 1? So that is why ma-alter din yung function natin dito. So halimbawa ito, this is any other number, so this is a squared. So ano kaya yung magiging forma niya if we make this be equal to 1? So let me change that. What would be its form when this is a squared minus u squared? Okay, because what we know from differentiation or from differential calculus is this. Okay, but how about if this is not equal to 1 or this is equal to any other constant? Okay, so to make this be equal to 1, para maging ganito siya na form, eto siya, divide natin siya by a squared. But remember, this is square root. So dapat eto divide natin by a. Okay, parang ganito na lang. So ulitin natin. So in order for this to be divided by a squared, kailangan eto siyang term, we divide this by a. Pag ipasok natin yung a sa loob ng radical sign, then it will become a squared. So therefore, para maging consistent or para ma-multiply natin siya by its identity, we need to multiply both the numerator and the denominator by the same value. Okay? So let's multiply this by 1 over a and also this by 1 over a. So this becomes 1 over a du over, eto siya, if we move this inside the radical, that would become 1 over a squared. So that's 1 over a squared times a squared minus u squared. So from here, eto siya, magiging 1 na siya. So this becomes 1 over a du divided by the square root of 1 minus u squared over a squared. And you can rewrite that as u over a squared. And we know that the derivative of u over a is du over a. So therefore, our function u is actually u over a. Kaya ito na siya. That's u over a. So if we have this form alone, the integral of that, or that came from the derivative of this, wherein the function is u over a. So if you do the same with, or you do the same checking with these two functions, then you will arrive at this, that is 1 over a times the arctangent of u over a, and for this, that is 1 over a times the arcsecant of u over a. So if you notice, tatlo lang yung sinali natin because eto siya, this could also give us an integral in the form of arc cosine, because if you recall sa differential calculus, yung equation ng arc sine at sa arc cosine only differs by the negative sign. Also with arc tangent and arc cotangent, and also for arc secant and arc cosecant. Okay, with the formulas given above, let us try to solve this function. So let us evaluate the integral of dx over the square root of 9 minus 4x squared. Parang medyo madali. This resembles the form du over the square root of a squared minus u squared. So from here, it's obvious that we will be using this will result to an arc sine. Okay? So if we let a na lang muna. If we let a squared equal to 9, so it follows that a is equal to 3. Right? And if we let u equal u squared, so this would be our a squared, this would be our u squared. Kasi siya yung naka-square root dyan. Okay, if u squared is equal to 4x squared, it follows that u is equal to 2x. Ayan. So, if u is equal to 2x, du, dito na lang, that would be 2 dx. Okay? So, if we reconstruct the integral of du over the square root of a squared minus u squared, we would be writing the integral of du, that's 2 dx, over the square root of a squared minus u squared. So, a squared minus u squared. Okay, so from there, it's obvious naman na the difference of these two is just the factor 2. So, we multiply this by 1/2. So, our answer would be 1/2 times the arc sine of u over a, which is 2x over 3 plus c. So, that is our answer. Okay, let's proceed to the next one. We have the integral of dx over x times the square root of 1 minus ln squared x. Okay, ito siya, may variable siya sa labas, but this cannot be arc second, because kung titingnan natin yung formulas ng arc second, it's variable minus constant. But in this case, it's constant minus variable. Okay? So, what resembles constant minus variable is arc sine pa rin. Ito, square root of constant minus variable. So, therefore, this is arc sine. Okay? So, if we let a be equal to 1, or no, a squared equal to 1, so it follows that a is equal to 1. And if we let u squared is equal to 4 ln squared x, it follows that u is equal to 2 ln x. And if u is equal to 2 ln x, du is equal to 2 times the derivative of ln x is just dx over x. Okay? So therefore, if we now reconstruct again the integral of du over square root of a squared minus u squared, which is the arc sine of u over a plus c, then we'll have the integral of 2 dx over x over the square root of 1 minus 4 ln squared x. So again, multiply this by 1/2 para maging pareho sila, and this x is actually this. Pwede natin ilagay siya sa baba. So meaning, this is now the same as this. So therefore, our answer is simply 1/2 arc sine u, which is 2 ln x, over a, which is 1, plus c, or simply that is 2 ln x. And that is our answer. Okay, let's have another one. We have to evaluate the integral of dy over 9y squared plus 6y plus 5. Okay, so what would be our approach here? Ito siya, this particular integral, this is second degree, and this is 0 degree. So therefore, this is not the case of du over u, right? Because pag du over u, 1 degree lower lang yung numerator than the denominator. But in this case, 2 degrees lower na siya. This is squared and this is 0, right? Now, among the formulas that we know here, isa lang yung walang square root. Only for this. Wala siyang square root. So therefore, we could say that this might be applicable here. Because remember, ito siya, this is second degree, this is 0 degree. Diba? So therefore, this could be applicable to this. But this is in the form constant squared plus u squared. Ito siya, trinomial. So that means we need to change this in the form a squared minus u squared. Okay? And we do that by completing the square. Diba? Completing the square. Oh, sorry. We change this into a squared plus u squared pala. A squared plus u squared. So, I'm sorry. So, we need to get, ano yung function dito na naka-square plus a constant squared. Anyway, pwede naman balik na rin because the operation is plus. Okay? So, the approach here is by completing the squares. Okay? Okay, let's look at the denominator. What number should we add to this that will make this that will add to this to make this a complete square trinomial? Okay, so if you recall completing the squares, if we have a function x squared plus, let's say, small letter na lang, bx plus c, wag natin lagyan ng c. So, what should we add here na perfect square trinomial siya? So, what we do, we divide this by 2 and then we square it. Right? So, we need to add here b squared, we need to add here b over 2 squared. So, that's b squared over 4. Okay, let's make this a perfect square trinomial. Oh no, eto lang. So if we consider 9y squared plus 6y, what should we add para maging perfect square trinomial siya? So if we divide all terms by 9, this would become y squared plus 6y over 9. Or that would be y squared plus, that would be 2/3. 2/3 y. So we need to add the half of this, then squared. Alright? The half of this, of course, is 2/3 times 1/2. That would be 1/3. And the square of 1/3 is 1/9. So we need to add 1/9. So this is now a perfect square trinomial. Now, if we multiply all terms by 9 again, so we'll have 9y squared plus, this would become 2 times 3. So 6y plus 1. So this is a perfect square trinomial. Okay? So therefore, if we write here 9y squared plus 6y plus 1, okay, plus 5 dito. So kulang pa tayo ng 4. So we just need to add 4. Okay? So this is the same as this. And this is a perfect square trinomial. Sorry, this should be dy. So that would be integral of dy over itong denominator, but this is actually the square of 3y plus 1. Right? 3y plus 1. So the square of that plus 4. So therefore, this is now in the form du over a squared, this is u function. Ulitin natin. Du over u squared plus a squared, which is eto, arctangent. Okay? So therefore, u squared is equal to 3y plus 1 squared. And a squared is equal to 4. Hence, u is just 3y plus 1 and du is just 3 dy. Okay? Now, a is obviously 2. Okay. So therefore, we know that the integral of du over a squared plus u squared is just equal to 1 over a arctangent u over a plus c. So therefore, our answer for this is just, i-reconstruct muna pala natin. So therefore, this should be 3 dy, or integral of 3 dy over 3y plus 1 squared plus 4. Okay? So, we multiply this by 1/3 para maging pareho sila. So, our answer is 1/3 times 1 over a. So, yung a natin is 2. So, times 1/2 arc tangent u, which is 3y plus 1 over a, which is 2 plus c. So, our answer is 1/6 arc tangent 3y plus 1 over 2 plus c. Uy, hindi na nakita. Yan. So, that is the answer. Our answer. Okay. This time, we have to evaluate the integral of this function. 3x minus 2 dx all over x squared plus 2x plus 17. Okay. Ito siya. It resembles a little bit like d over u, right? Because, tingnan nyo, wala siyang square root, firstly. So, we have an idea, or we might suspect that this is arctangent. Pero, linear yung nasa numerator. The difference between the degree is only 1. Tingnan nyo. This is second degree and this is linear or first degree. So therefore, we cannot immediately say that this is arctangent. It actually resembles du over u. Okay? du over u. Because the difference in the degree is just 1. Okay, so what would be our approach to this? For this to be du over u, this should be u. And the numerator should be the derivative of this denominator. Pero, if we let, dito, change natin color. If we let u, zoom out tayo konti. If we let u be equal to x squared plus 2x plus 17, okay, the derivative of that, du, is 2x plus 2, which is not 3x minus 2. Okay, sorry, wala pang dx. So, iba siya, no? So, the best thing we could do here is i-fit natin yung denominator sa numerator. So, ito yung gagamitin natin. How about, we'll make this in the form du over u. Dun yung first approach natin. So, to do that, if our denominator is x squared plus 2x plus 17, pero i-manipulate ulit din natin yung denominator mamaya. Its numerator should be 2x plus 2 dx. Dito ka na lang ilagay yung dx. But this is not the same as this. So, di gawin natin the same. Let's make it the same. So, anong pwedeng gawin natin dito? How do we manipulate this na magiging ganito siya? Okay. Kailangan i-change natin yung 2 into 3. So, meaning I need to remove 2 here and multiply this by 3. Diba? So, meaning, if I multiply this by 3 halves, eto siya magiging 3x. Ayan. Okay? So, tingnan natin. So, this would be 3 halves times 2x. That would be 3x. And 3 halves times 2, that would be 3. Minus 2, dapat siya. Diba? So, pero 3 dito. So, we need to subtract 5 because 3 minus 5 is 2. So, meaning, we need to subtract here 5. Okay? So, take a look at this. That is now equal to this. Right? So, the same na sila. Now, let us separate the two terms. So, therefore, I'll have 3 halves times the integral of, so I'll start with this, 2x plus 2 over x squared plus 2x plus 17 dx, then minus 5 integral of dx over x squared plus 2x plus 17. So this is now clearly du over u. And this is now arctangent because second degree, 0 degree. Okay. So yung first term, madali na lang. That is just 3 halves times ln u because the integral of du over u is just ln u. So ln u. So ln x squared plus 2x plus 17. Okay. Then minus 5 times the integral of this. So for the integral of this, we will approach this or we will solve this using ito in the previous problem. So we'll do that by completing the squares again. So this is the integral of dx over x squared plus 2x. Remember that 2x or 2 divided by 2 is 1. 1 squared is 1. So I need to add 1 here. So x squared plus 2x plus 1 is a perfect square trinomial, and we just need to add 16 for this to be equal to 17. So this is now the same as this. Now, sige, isa-isa na lang natin. So let me copy this. Okay, but here, eto na, this is now in the form x plus 1 squared plus 16. And obviously here, u is x plus 1 and a is 4, right? Because u squared is equal to this and 4 squared or a squared is equal to 16. And the derivative of u is just dx. So, sakto na, wala tayong i-manipulate dyan. So, our final answer would be 3 halves ln x squared plus 2x plus 17 minus 5 times 1 over a arc tangent u over a plus c. Okay, so our final answer is, I'll just change this to 5 over 4. So this is our final answer. Very easy. So for your assignment, you solve for this integral and I will ask you to discuss your answer during our synchronous class.